Hey, Bogdan Brzeski here, another video. In this video, quadratic functions introduction. So let's dive in. So you're probably familiar with those U-shaped curves that we call parabolas. And we will be focusing on quadratic functions in terms of Cartesian plane. So oftentimes you will be seeing a statement y is equal x squared plus bx plus c with the following requirements that a is not equal to 0. So coefficient b and c can be 0, but not the leading coefficient a. We'll be always interested in observing or making note, if a is positive, how does it impact the shape of the parabola? If a is negative, how does impact the direction of opening of a parabola in comparison to positive a, and also the key feature like a vertex, y-intercept, x-intercept, if available, axis of symmetry, and minimum value, maximum value, things like that will be discussed in this series of video. For now, we're just introducing parabolas, starting with a very sort of a simple idea. You probably have seen parabolas in real life application in sports, science, technology. Sometimes in nature you can build an equation that you will see that the correlation is close to 100 or very or even sometimes, in fact, depending on what points you select, and that also can be transformed into quadratic function. In mathematics, however, we'll be focusing, as I said already, on those key elements like vertex, y-intercepts, x-intercepts, directions of opening, etc. So let's dive in. So the first example we'll be calling parent function y is equal to x squared. Stems from that general sort of equation where b and c is 0 this time, a is equal to 1, and a is positive. So when a is positive, you will see in the moment that the graph opens in upward direction, and that is sort of the basic parabolic shape that we can sort of discuss, and the feature of that graph also based on the elements that I found in this picture. So I use Desmos to create the graph, and you can add a graph by going to Desmos, and this add sign, that plus menu, drop down menu, allows you to select table. So you can input couple negative, couple positive values. There is no how to do it, like how many. I prefer to do several because it is easier to observe the pattern and the shape of the graph. And a couple negative, a couple positive with 0, that gives me a nice sort of a spread. And the second column, which is the result, right? When x is equal to whatever the number raised to the power of 2 gives you the output. So you can calculate yourself, or you can enter in the second column x squared, which represents the equation of the function, and the software will populate the numbers for you. So you start observing the location of those points on the grid by looking at that picture that I have included in this video. So you see that for -4, x is -4, y is 16, and for +4, y is also 16. So there's like a symmetry at the same level, the same height, if you will. Same goes for -3, +3, you get 9 and 9, -2, +2, -1 and 1. So you start seeing that the graph is symmetrical in the y-axis. There is also a point on the graph that it's called the turning point, a vertex of the parabola, where the graph changes direction. You always read graphs scanning the x-axis from negative infinity, left towards right. Always consistently do that. Then you observe how this shape is developing. So this is like a falling down parabolic curve, then you start turning around 0, and when you pass 0, you start increasing. So those two branches, the left side and the right side branches of parabola, are symmetrical in that axis of symmetry. So now you become familiar or maybe aware that parabola has a vertex, parabola has axis of symmetry, and parabola has a direction of opening. So then another example that we will walk you through this, where it shows 3x squared plus 12x plus 12. And in this example, it happens to be that the parabola sits somewhere else, away from that 0, 0 origin. So it was transformed, was shifted to the left by a couple of units, and the vertex still sits on the x-axis. Now, when you use Desmos and when you plug in y equals to a certain expression, or you just do an expression with no y equals or f of x equals, it is going to generate a function. If you, however, put the formula and then you make it equal to 0, it will show you, if there are solutions, it will show you a vertical line. So please make a distinction. When you input a formula and make it equal to 0, it is not representing a function. It does represent an equation, and it provides solutions without telling you how the solution was generated. But if the solution does exist, you will see a vertical line. If in this particular case, the vertical line coincides with axis of symmetry, because the vertex has x and y coordinates always. And the vertex x coordinates coincide with the axis of symmetry. So when x is equal to -2, the axis of symmetry equation, you would write down x is equal to -2 as an equation of axis of symmetry. In the second graph, where the x-intercept and vertex coincide as well, and it is equal to +3, so the axis of symmetry passes through that x is equal to 3. It is a vertical line. So now we have the direction of the opening depends on the value of a. So we understand positive a creates parabola, opens up. So that's the concavity, also concave up. And when a is negative, so then the direction of the opening is down, concave down. And the role of this vertex, for example, here, it's a minimum, it's the lowest point on the graph. So later you will be introduced to the minimum maximum concept of the function. And this is the maximum point. This is the highest point. This is the peak value on the graph. So another example that we will introduce here is a parabola that doesn't show a vertex on x-axis. And this is the parabola that it doesn't show x-intercepts, because it is located with the coordinates of the vertex at 2 and 5. So there is no way that it will intersect x-axis. So x-intercept may not be always available. And that sort of makes sense because when you did equations, and sometimes there were no solutions. So now you can sort of make that connection. No solutions meant the graph must have been away from the x-axis. Each parabola has axis of symmetry regardless of the x-intercept. Each parabola has y-intercept because x is always equal to 0, and then you find y when x is equal to 0. So you can always find y-intercept, but you may not be able to find x-intercept all the time. There is a form of parabola that is called the vertex form. I'll tell you later how that is developed. But for now, when you enter using that form, it allows you to identify the vertex coordinates directly from the form. So for example, 3 in bracket x minus 2 plus 5, so it tells me that the vertex is at 2 and 5. And positive 3 tells me parabola opens up, and also the axis of symmetry is at 2 because coincide with the x coordinates of the vertex. And also that line of this point, the vertex, is the minimum value, the lowest point on the graph. Conversely here, this example, it shows parabola that opens down, and the vertex has coordinates both x and y are negative. But even though they're both negative, we can identify this vertex as a maximum value of the function because this is the highest point on the graph. No x-intercept. Yes, there is axis of symmetry that passes through the vertex, and there is always y-intercept because when x is equal to 0, we can quickly identify using the formula. So whether you use the standard or vertex form, you can always calculate the y-intercept because x is equal to 0. So basically, this is the graphs, parabolas that we'll be talking about in greater details in another video. For the meantime, do the practice questions and identify coordinates of the vertex if you can. Use the Desmos software to sort of visualize how the graph looks like. Identify direction of the opening, axis of symmetry, and don't forget to share that video. Hopefully you'll have some comments down below. We'll see you in the next video. Bye for now.